Volumes by cylindrical shells. Using the shell method, the volume is the integral of the product of the circumference, which is 2 pi, times the radius times the height of the shell times the thickness. The thickness is either delta y or delta x or dy dx. For example, set up the integral for the volume of the solid obtained by rotating the region bounded by x equals 8 sine y, where y is between 0 and pi, the line x equals 0, which is the y-axis, about the line y equals 4. Then use the calculator to evaluate the integral correct to 4 decimal places. Usually, I use decimals.com to evaluate the integral if you have access to decimals. Always draw the bounded region. As usual, the x-axis and the y-axis are the help lines only. They are not part of the bounded region unless stated in the problem. The region is bounded by the curve x equals a, the square root of sine y. When y is 0, x is 0. When y is pi, x is pi. And when y is pi over 2, x is 8. The region is bounded by the curve from y equal to 0 to y equals pi and x equals 0. X equals 0 is the y-axis. So this line is x equals 0. As we can see, the two curves along with the interval 0 to pi along the y-axis form the enclosed region. We then take this region and rotate it about the line y equals 4. Pi is roughly 3.14, so 4 is above pi. This bounded region is being rotated about the line y equals 4, so we would end up with the mirror image on the side of y equals 4. Y equals 4, think of it as the mirror. To find the volume of the solid, we will attempt to use the washer method to see what happens. If we were to use the washer method, then we will slide the solid perpendicular to the axis of rotation, which is y equals 4. We would therefore obtain an annulus. Using the washer methods, the inner radius is from the axis of rotation to the curve, and the outer radius is also from the axis of rotation to the same curve. This will pose a problem because we want to have two distinct expressions, one for the inner radius and one for the outer radius, and we won't be able to do that because the two curves, which is the same curve, it shares the same equation. Washer method is not a good choice. With cylindrical shell method, we draw the cross-section parallel to the axis of rotation to form a representative shell. The volume of this representative shell is 2 pi times the radius times the height times the thickness. But since we draw the cross-section parallel to the axis of rotation, which is y equals 4, the cross-section is therefore perpendicular to the y-axis. Thus, the thickness is delta y. As usual, we label the point on the curve at the cross-section x, y. That means the horizontal distance from the origin to the point is x, and the vertical distance from the origin to the point is y. But in this case, we are interested in the radius of the shell, which is from the axis of rotation to the point x. The radius is this vertical distance, And to find the vertical distance, we take the upper minus the lower. Thus, the radius is y equals 4 upper minus y lower. The height of the shell is the distance x. But in terms of y, x is 8 the square root of sine y. Thus the volume of the cross section is 2 pi times 4 minus y. The height is 8 the square root of sine y, and the thickness is delta y. We then simplify it to 16 pi times 4 minus y times the square root of sine y times delta y. But this is the volume of the ith cross section, so we would properly label this as yi, yi. The total volume is approximately the sum of n of these volumes at I go from 1 to n. But each of these volume is 16 pi 4 minus yi, the square root of sine of yi, delta y. As n goes to infinity, we obtain the exact volume as the integral. The Riemann sums turn to the integral 16 pi 4 minus y. We drop the subscript I. The square root of sine of y, delta y is now dy. The lower and the limits of integrations are obtained by looking at the limit where we added the shells. We added the shell from 0 to pi. That the lower limit of integration is 0 and the upper limit of integration is pi. If we were to do this on decimals, we would obtain approximately 292.59805, which we rounded to 4 decimal places, 5981.